Okay, section 7.6 is on properties of systems of linear equations. So when you're solving a linear system, there are three possible results you can have. The lines can cross over each other in one point, which would mean there'd be one solution. That will only happen when the slopes are different. When you have the lines not crossing over at all, that would mean that the lines are parallel and there'd be no solution because there is no common point for parallel lines. And that will happen when you're looking at the equations if the slopes are equal but the intercepts are different. And the last case is if the two equations in your system represent the same line. And a lot of times when you're looking at the system, you can't tell right away by looking at it that they represent the same line, but if you change them both to slope-intercept form, they will look identical. So that would mean that they would have the same slopes and the same y-intercepts, and also, if you check them, the same x-intercepts. So if the two equations represent the same line, then everything that's a point on one line would be a solution to the other line as well. So there'd be infinite solutions. And the slopes, when you're looking, as I said, at the equations of those lines, the slopes should be equal and the intercepts should be equal. So slope-intercept form, you'd have the same m value for the slope and the same b value for the y-intercept. All right, so an easy way to determine the number of solutions, if you're only interested in the number of solutions, not necessarily the exact solution, is to just compare the slopes and the intercepts of your lines. So first example here asks us to determine the number of solutions of each of the linear systems. So the first one there is x plus y equals 3 and negative 2x minus y equals negative 2. And when you look at it like the way that it's written there, you can't really tell what the slopes and y-intercepts are. So the first thing we should do for each of these examples is to change the equations to slope-intercept form. Again, if we were looking for the exact solution, we wouldn't bother doing this because we would need to eventually go on and solve either algebraically or graphically, more than likely algebraically. But because they're only asking the number of solutions, the easiest thing to do would be to change them to slope-intercept form. Okay, so the first equation, we have x plus y equals 3. So if we change that to slope-intercept form, we would have the y by itself, and the x would need to be brought over to the other side. So that would be subtracting x from both sides. So you'd end up with negative x plus 3 on the other side. And then the second equation is negative 2x minus y equals negative 2. So if we rewrote that into slope-intercept form, we'd first isolate the y, so it'd be negative y. And then that negative 2x would come over to the other side as a positive 2x, and there's already a negative 2 on that side. And then the next thing we'd have to do is divide all the terms by the negative that's in front of y, which is understood to be a negative 1. So we're going to divide everything by negative 1. And that's going to give you y equals negative 2x plus 2. Because negative 2 divided by negative 1 is going to be positive 2. So because the slopes are different, we don't need to go any further. Slope of the first one would be negative 1. Slope of the second equation would be negative 2. So therefore, there's only one solution. And question B. If we change the first equation, 4x plus 6y equals negative 10 to slope-intercept form, that will give you 6y equal negative 4x minus 10, and then divide out your 6, and you're going to get y equals negative 4 over 6 reduces to negative 2 over 3 x, and that's negative 10 over 6 reduces to negative 5 over 3. So your slope of that one would be negative 2/3, and the y-intercept would be negative 5 over 3. And then your second equation would be negative 2x minus 3y equals 5. So if we change that slope-intercept form, it would be negative 3y equals negative 2x would come over the other side as a positive 2x plus 5, and then divide out the negative 3. And that will give you y equals a negative 2/3 x minus 5 over 3. So you can see both those equations are exactly the same. So therefore, if they have the same slopes and intercepts, if they're the exact same equation, that means there are many solutions, infinitely many solutions. And the last equation, don't have a whole lot of room there. Let's see if we can move the page up a little bit. Maybe if I could write here. So if I take C, no, it won't let me write down here. Oh. C, this would give you 2x minus 4y equals negative 1. So if I rewrote that, I would get negative 4y, bring the 2x over, become a negative 2x, minus 1, and then I divide out the negative 4, and that would give me y equals 1/2. Negative 2 over negative 4 is positive 2 over 4, which reduces to a half, and this would be positive 1/4. And the other equation, let's move that up a little bit more there. This is as far as it can go. It's all right. Okay, we'll squeeze it in here. So this would be 3x minus 6y equals 2. So then if I rewrote that, I would get negative 6y equals negative 3x plus 2. Then divide out the negative 6. And then that would give me y equals negative 3 over negative 6 reduces to 1/2, positive 1/2 x, minus 1/3. So these ones have same slopes, different intercepts, which means the lines are parallel, so there's no solution. Okay, example 2 is on creating a linear system with 0, 1, or infinite solutions. So given the equation negative 6x plus y equals 3, you're asked to write another linear equation that will form a linear system with A, exactly one solution, or B, no solution, or C, infinite solutions. So the first thing I would do there, because we're only asked to come up with a linear equation, not actually solve it or anything, we just need to come up with the equation. We'd like to know what the slope and y-intercept is of our given equation so that we can easily come up with answers to A, B, and C. So the first thing we're going to do is change this to y equals positive 6x plus 3. That's slope-intercept form. So you can easily tell now that the slope of the given equation is 6 and that the y-intercept is 3. So if you're looking for an equation that has exactly one solution, when you match it up with that given equation, you would need to find an equation that has a different slope than the one we're given. So that would be, for example, and there's tons of different examples, so long as you have a different slope, it would be correct, 2x minus 1. So an example of the system would be negative 6x plus y equals 3 is our given equation, and y equals 2x plus 1 would be a system, but which only has one solution. If we were looking for an equation to match up with the given equation so that there's no solution to the system, we would need same slopes but different intercept, because they would need to be parallel. Same slope, different intercepts. So an example of one of those equations would be something that has a slope that's the same as a given equation, would have to have a 6 in front of the x, but a different y-intercept than 3, so we can just say plus 2. So therefore the example of the system would be a negative 6x plus y equals 3, and y equals 6x plus 2. And that would be your system, which has no solution because the lines would be parallel. In the last example there, you're asked to come up with another equation so that the given system would be one with infinite solutions. So that would mean you would need the same slope, an equation with the same slope, and the same intercepts. So the easiest thing to do is to take the exact same equation, y equals 6x plus 3, that was given to us. But if you don't want to be as obvious with the exact same equation, you could just basically multiply both sides of the equation by the same constant. So for example 2, multiply the left side by 2, I get 2y. And if I multiply each term on the right side by 2, I get 12x plus 6. So that would mean our system would be negative 6x plus y equals 3 was the given equation that we had, and then we can combine it with 2y equals 12x plus 6. And because those would be the exact same equation when you change both to slope-intercept form, there would be infinite solutions because it would be the exact same line. So that's it for that section. There's some questions there. It's a nice short section. There's some questions there for you to try in the textbook, pages 448 to 449, and you can try those questions for practice on these topics.